Live from the Icebox Studio in Montgomeryville, Pennsylvania. This is the Bill and Corey Show.
I'm Bill.
And I'm Corey.
Welcome back to another live edition. Sneeze button, so hopefully we won't need that issue. So this week, we're going to talk about leak detection.
Leeks.
Leeks. Oh boy, he's got leeks right there. I see
delightfully scrumptious root vegetable. You know, when I was a kid, my dad and I used to go pick wild leeks.
Oh, wow.
Yeah, what I figured out when I saw them in the store, we never had these in our stores where I grew up. I grew up really rural.
So you just went out and got them?
Went out and got them, and technically they're not leeks. They look like scallions, and I can't remember what they technically are, but they're a different variety. But just
make soup out of them?
Oh yeah, colloquially, yeah, they were pungent and delicious. But anyways, I digress.
So that's a leek. We can detect it with your eyes. So if you see that
smell,
if you see that growing out of your pipe, you got a leak. So, there's a lot of different ways to determine leaks in your piping or your system. Part of it is actually sight. If the gas or liquids color.
Yeah,
actually, if it's water, you can see the
famously
water
in
leak.
movies, you stop the bad guy from running after you by hitting the valve, and the steam comes out.
That's a leak.
That's a leak.
You can see that. Sometimes you can hear leaks. We've had some customers like this certain safety relief valve, and it'll say that you'll get an audible leak at like 20% of the set value, so you could hear a leak.
And sometimes you can change the leak sound like you can on your navigation system.
Oh boy, I don't know about that.
No, okay.
You could also feel sometimes people put their hand over a pipe and can kind of feel the gas coming out.
Don't do that for hydraulics.
That's not the you get all messy. So that's kind of like that's not the best way of leak detection. So
I just want to add real quick, and one thing that we run into with hearing is sometimes we'll hear it come through the weep hole and think they hear a leak in a regulator.
Oh, right. You could hear something and think it's a leak, and
yeah,
it's not a
leak.
So we're going to talk about really 4 different ways of leak detection. The first one that we use called a snoop test, and that's we did that with nitrogen, and that would be Corey can demonstrate that. Well, don't squeeze stuff out.
Okay.
We're gonna have to actually sell that.
So what you do is you take your Snoop.
Yeah, it's like a special soapy solution.
Yeah, nothing to do with peanuts.
No. Not Snoopy, not Snoop Dogg. No, leave the cap on.
Oh yeah, I wasn't gonna do. Yeah. So what you would do is you'd fill this up and you'd close it off and wherever there's
pressurize it.
You pressurize it. So fill it up, pressurize it. Pressurize is good, better than fill it up. And then you take this and
anchor it.
You put it where all the connections are.
So you just put it at like the pipe threads.
The pipe threads in this one.
Yeah.
Or if there's a weld, maybe you can do.
Yeah, you could do.
I mean, it's more dye penetrant. It depends on what weld you're doing. I don't want to get into that.
Well, if you got a welded system, you should do. But anyways, that's a way of checking for leaks. And this is typically used on industrial grade equipment and regulators. And these have like a rubber diaphragm, neoprene type diaphragm.
And it's the same idea of what we would do with a flex hose, essentially, is if you just stick it in water or something.
Or that's another way too. Is that
the same principle?
You got a flex hose just like you have like a bicycle tire.
Oh yeah, there you go.
They would take flex hoses, and the good thing about this is you can do a whole batch of flex hoses. You put them in a tank of water. And then you look for bubbles after a certain amount of time. You don't just put them in there for 5 seconds. Go, oh, that's good. Take them out. We don't manufacture hoses here. I'm not sure how long you'd stick it in there. If we stick it in for a set amount of time, and you'd look for bubbles, and that would tell you there are leaks. That's another way of doing it. So yeah. So then we get a little more sophisticated because nitrogen, it's a relatively big molecule. As compared to helium, your next level up is to pressurize the system with helium. And helium, small.
What's wrong with hydrogen?
Oh well, you could use hydrogen, but hydrogen likes to explode.
That's right. There's a famous disaster in New Jersey.
Some big balloon thing.
A balloon.
Had a leak.
Now nobody.
Everybody's afraid of. No, it
it
should be afraid.
Yeah. There's a reason.
So this would be, you do the helium leak test. Well, the reason you don't do helium on rubber diaphragm is the helium's going to leak through it.
Yeah, it's weird to think about the idea of because to us, everything is it's all tiny. Every molecule, every element is tiny. But if you add, more protons onto it, it gets a little bit big to these cracks. It's weird to think about like how oxygen could clog a leak that hydrogen could pass through.
Yeah. So that's why you don't do the helium leak test on these, because you'd get a leak and it'd be like, it's leaking, yes, but you're not using that for helium.
It's leaking at the rate it should if you use helium.
Yeah. So this would be like our bar stock regulators. It would be ones with stainless steel diaphragm,
which is less porous than
the
rubber
diaphragm, rubber neoprene, or whatever.
So it's the port,
So what you do on that is, well, you could just use Snoop, but you're going to get a little more sophisticated with this stuff. So we go with we'll go with a thermal conductivity leak detector.
Ooh, that sounds fancy.
Oh, geez, it does sound fancy. So we use this Galmac. Our production techs love this. It's got a neat little
little gauge of sorts.
Gauge
The needle.
So you can see the needle go back and forth depending on what you have.
We should get a printout of that needle too. It'll be,
No, we don't. So it's got a needle that goes back and forth, so you can kind of see it, and you can see it'll go in one direction for something like a helium, and if you get a heavier thing, like if you get moisture, it'll go in the other. You'll get if you got some wet stuff, you might go down in the other direction, so you can kind of see the difference there. Yeah. So this can measure.
It'll detect the Snoop you just used on your.
Yeah, just detect a Snoop that's bubbling off, and you go, oh, geez, it's just a Snoop. So yeah, you don't want to. You're gonna make a big mess. You're doing all this stuff. This will detect leaks to 1 × 10⁻⁵ cc's a second of helium. What is that? It's like, okay, that's just some number. It's like, okay, you gotta.
It's right there. You can see it in my hand.
Yeah, it's just. So that is the equivalent of 1 cubic centimeter. I don't know really how big is cubic centimeter.
Like a sugar cube.
That would be 1 cubic centimeter over 24 hours. So that's a pretty good leak. So yes, so that's what 1 × 10⁻⁵ cc's
pretty good.
is. So that's pretty good, and it's going to work great for a lot of things. So how do these things work? Well, explain another thermal conductivity detector that we have. We don't sell this. This is used in the plant, and you can't buy these anymore.
Yeah, I don't think.
We love it, so we got all of them in the whole world, I think.
They're all here.
We sell our 8066 leak detector. Where can you buy this?
Store.mathesongas.com.
And you can buy this, maybe eBay, but I think we bought them all.
The CIA tried to buy one of these off of us once. We had to explain to them it's not that type of leak.
Oh, boy. Okay, this will detect different gases. Now, it has these thermal conductivity detect. This one is actually more sensitive. This will go down to 5 × 10⁻⁶.
And sensitive in a good way.
cc's of helium. Yeah, it's sensitive in a good way. It's not going to get upset at you if you're wearing the wrong color shirt. Your shirt and your socks don't match. It won't get that uptight on you. I'm in trouble for that one. Okay. So what this works is it's got a pump in here that pulls in the sample. And what happens? The instrument will respond to any gas mixture that has a thermal conductivity. There's that word again.
Thermal conductivity.
Value different from air. So what it does is it senses a temperature fluctuation in a heated filament or wire. Filament's just a fancy word for it's a fancy wire.
In the light bulb.
It's like
filaments in your light bulb.
It's a fancy wire. Okay, so you're like, okay, that still doesn't make any change. Now, we all understand wind chill.
Oh, yes, we do.
So I brought a fan.
Go outside on a
I went up the attic this morning, a little chilly up there. I got a fan.
Well, that's because you didn't turn your fan off. You had to turn it off when you got up there.
So you think a wind chill is if air blows and you get cold, and so if gas carried away the heat from your body better than air, that's thermal conductivity. It's a higher thermal conductivity, and you get colder faster.
It's like if you have water on your arm.
Yeah, that is a higher thermal conductivity.
And it blows on, you feel colder.
Yeah, so it's all like wind chill. So thermoconductivity is like wind chill. Thermal conductivity is another one of those terms you can use at an engineering cocktail party, and something comes
like,
up.
Yeah.
Yeah. What about the thermal conductivity? So if you had helium blowing across, if you're in a helium atmosphere, you'd be dead. You'd have a high voice.
You'd have a high voice.
But you'd get colder faster.
Help!
You get colder faster. So what we're going to show is, you want to pop up the first graphic. This shows some thermal conductivities. That's room temperature, 300 K. So that's kind of
And
fancy.
I know, my skin can tell the difference between those numbers.
Yeah, I just can't.
Well, that feels like helium.
So air, which you'd zero the detector out in air. That's 0.026. I don't know, watts per. I don't know, something.
Watts per millikelvin, it looks like.
So I don't know what it is. And then helium, you see, is 0.151, so it's a lot higher number. So it's like what, 6 times?
No, I was gonna go with it's only 0.12.
But it's like it's about 6 times.
I know.
Better.
I know. It's better if you say 6
and
times.
hydrogen's even better too. So people actually use hydrogen for cooling. And don't do that though. It's because you can get all sorts of issues. But for sophisticated systems.
What about liquid hydrogen?
No, we won't get into that. That's other issues. Yeah, so you can take that down.
And I wanna nip this one in the bud. Technically, you can detect air with our leak detector, but you have to zero it out in a non-air environment.
So really, yeah, anything to thermal conductivity is different. And you saw in that chart, you had something like argon, it's going to detect argon.
It's going to detect argon.
Yeah.
But we do get the question once in a while, can it detect a leak of air if you have air in your system? And it's like,
really not.
It technically can.
You would go with Snoop. Snoop's cheaper.
Yes.
It's not as fancy. It doesn't have like things that light up. They don't have needles going back and forth. But it works. And now, if you want to get more sophisticated.
Oh, even more. I need to get my monocle out.
This is for, so you've got analytical grade equipment. Then you get into the semiconductor grade. And that stuff, you're talking about parts per billion, not parts per million. And it's just really crazy purity stuff. And leaks are serious stuff. Well, I mean, leaks are serious anyways. But
in a dam, they're serious. They're
serious. Everything. Yeah, water. Yes, this is. But a dam leak's probably more important than a leaky regulator.
Yeah, probably.
Okay. So what a mass spectrometer does, we use a Vico MS40. It pulls a vacuum on the system. It pulls a vacuum on the system. So you'd have, let's say you got this regulator hooked up. And so it pulls a vacuum, and then you use this little guy, and or girl, or whatever, doesn't have a sex. So, and it has helium, and it would spray helium, so you'd like spray a little bit of helium around places that might leak. And places might leak would be CGA connection, pipe thread fittings, maybe around the gauge. Gauge's got a lot of things going on. You'd snoop probably in the bonnet vent hole, all the little, not snoop it, you'd spray the helium. And
it's kind of funny
so that's some serious stuff. So it's sucking in helium. And what it does is it's got, the mass spectrometer looks for helium in there. And what it does is it's another fancy term, but if you think of like, you got an object, and
you forgot the bowling ball, didn't you?
I forgot the bowling ball. Sorry. Let's say you got a bowling ball, or a tennis. Compare a bowling ball to a tennis ball, and then you got some water. So you got a hose, and a bowling ball's rolling, and you hit it with the hose.
It doesn't move very far.
It's not going to move very far. Now you do that with a tennis ball, it's going to go flying. It's going to be fun. You do that with kids. Send it down the driveway. Something like dog chasing. That's more fun.
Well, kids are fun.
Get all excited. The kids won't pick it up.
Sad when they grow out of that age.
Yeah, I know. So what it does is it sucks in the gas and it throws ions at it. That's like a little positive charged particles, sticks on it. And then it's got a magnet. So think a bowling ball, and now it's like magnetized, and then it goes through a magnet. It's going to move not as far as something light.
Yeah.
So that's how it detects that. It's got real fancy stuff. You want to, and I can't explain all that. It would take too long.
I mean,
you want to pop up the next image?
It just doesn't make for good TV.
Oh, actually, I'm sorry. That's oh no, put that back.
Uh-oh, what is that?
There we go. That's actually a semiconductor grade panel there, and we call it an inboard leak test. So we'd attach the Vico to the outlet, pull a vacuum, and you have to wait a while for the vacuum to get down. So quite a while, and then you would spray helium at the different joints looking for a leak. So it's quite an extensive process. That's a really good photo.
And then right afterwards, you can clean up your mess from lunch.
Yeah, just not with the helium. So, okay, and then the next one will show the Vico itself. There it is. That's what the Vico. That's yeah,
That looks.
they're old, but we get.
That looks like it could run on steam.
It looks. They work great. You have to
if it ain't broke, don't fix it. I'm not saying it.
And we get a technician coming in. I don't know how often, maybe once a year, to make sure they're all good and running and stuff like that.
Yeah.
So, yeah, so that's used on semiconductor grade systems, and so you can take the image down, and then we get to the last thing. So we got all this sophisticated. So we've gone from looking and sniffing. We got the soapy water, fancy soapy water. We got the thermal conductivity, the mass spec.
We're getting fancier and fancier.
And you're just thinking like, oh, geez, I got a regulator in my lab. Do I need all this stuff? No. Well, we leak check these things before we ship them, so it's
because
good.
It's quicker.
It's quicker than selling.
It's quicker than this. Hold on, it's quicker than this.
Okay, no. So you've got this, and you're putting it on your cylinder, and you want to make sure you don't have a leak. So there's and this is another test that you can do. It's called a pressure decay test, and we occasionally do this for sophisticated customers. That well, there's sometimes you
some
do
of our
all this
customers
stuff.
are like, they've never done this test for me.
Yeah, it's just, we're going to be doing more of this. And the production techs are going to be real angry at me trying to do this. So sometimes we do, for a system like that panel, we'll do a 24-hour pressure decay test. So what we do there is we pressurize it up, and then we shut off the supply valve to it, and we let it sit for
out of all the words
24 hours.
And out of all the words to use, decay sounds pretty cool.
Yeah,
it's
so
pretty
it's
cool.
rotting away. No,
Yeah.
it's just, so what you
the
do...
pressure change test.
So
this doesn't have the same
What you
ring
do
to it.
on that is they would, and you could use it, they would mark, the production techs would mark the gauge on what pressure. Let's say you pressurize it up to 2,000.
And take pictures.
They mark that, they mark the other gauges, and then they wait 24 hours. And then they'd see
until we build that time machine. Until we buy
the time, no, just. And then what you also have to do is measure the temperature, because with gas laws, I don't know if it's Boyle's or Charles' law.
And I don't know who passed this.
That when temperature goes down, pressure is going to go down. So if you have this at 70 degrees and then the heat goes off and it gets down to like 30 degrees overnight, the pressure gauge is going to go down a little bit. So you have to compensate for that. And that can be annoying. But in a lab, it is. You're like, oh, geez.
But you know it's going to happen.
So you're not going to do
You're
not doing a 24-hour pressure decay test when you have your regulator.
Yeah.
So you hook your regulator up to your cylinder. We can't have a cylinder in here, safety reasons. So you tighten this up, and then you would you would back out the regulator, so the knob's loose. That means the delivery pressure is 0. So you'd pressurize this side, and you'd see the gauge go up. Get the little needle to look at, so it's kind of fun.
That's the visual.
That's visual thing. It doesn't say whoosh.
Make sure you're wearing your
glasses.
glasses.
Pressurize it up, and then you close off your cylinder valve. Yes, of course you wear your safety glasses.
I meant glasses so you can read it properly. You're reading glasses.
Well. So you shut off the cylinder valve, and then gas is trapped in here, and you wait. If you wait 5 minutes, and it doesn't go down, then it's in pretty good shape. Most likely your leak is going to be at the cylinder connection.
Yes.
That's because that's the one you just made. The other ones have been there, they ain't moving. And then the next step is, actually I forgot, you'd have this valve, outlet valve closed.
It goes without saying.
Yeah, you go, okay. You go that. So also what happens when you do that is that this shouldn't go down. And well, if it does go down, this could go up. And if it goes up, it tells you either you had the regulator set at a pressure or there's regulator creep. So you have to investigate that.
Yeah, so depending on which gauge moves, it can tell you where the leak...
Well, this will go down if this goes up.
Yeah.
So you do that. So this side is now, you figure, okay, leak's good on, no leaks on this side. And then you open up your cylinder valve again, pressurize it up, and then crank in a little pressure. And then the needle will go up to a decent pressure. And you usually put it in like a whole number.
Yeah.
And then
round number.
you close the cylinder valve, and then you'd see if there's any leaks
from here over.
Yeah, so it could be a leak here, it could be a leak here, it could be a leak past the valve. And then you investigate that. And if you got a system, then you just kind of go isolate different parts of your system.
Each time, so you can just open up downstream of it.
Yeah,
and see
downstream
if the
to see if it drops and
see
stuff
if
like that.
the gauge drops.
And you know, it's not the most perfect way
No.
thing, but it'll give you a good idea if you got leaks. Of course, if you're using toxic gases, it should be under a hood, or it should be anyways, or in a cabinet.
Always take all safety precautions.
Yeah, so you gotta
don't literally go around sniffing all the gases.
No, you don't want to do that.
You don't want to do that. My kids, I do that. I detect leaks of my kids by that way, but it's not the way.
I heard about a guy, place I used to work, that did sniff tests with carbon monoxide and ended up on the floor.
Really?
So,
Yeah.
I won't say any names, but yeah, that's the guy. That's what I heard from that this guy did. So we don't have any questions. So that's kind of all the questions we got. Or, not all the questions, really the one net topic. So
yeah,
that's all.
All
Anything
the
else you want to
topics
add about leak detection?
No.
So there's a lot of different ways to check for leaks. It's important to check for leaks. You don't want to have, you don't want to lose product. You don't want to endanger yourself. You don't want to start a fire and that kind of stuff.
You don't want to prematurely wear down your components with leaks as well. Like
Right.
Corrosive could do that.
Yes. Yeah, corrosive gas, you can see like corrosion coming.
You can, That's
Hey,
that's
there's corrosion there.
It's usually
Maybe it's a leak. And we've seen that. We've gotten, some people have, what's that, got corrosion here? Yeah, you got a leak.
well, you got to make sure that it's not environmental at that point too, perhaps.
Right. Okay, so
No, but
next week, our topic is going to be a 5500 series 5-valve panel for analytical gas use. So we're going to answer some of the questions we're going to answer. Why would you ever want one of these 5-valve panels?
And how does it work?
How does it work? And how come you have 6 valves on there and you call it a 5-valve panel? Sometimes you have 6, sometimes you have 5.
It's
still a 5-valve panel. We'll explain that. So it's
We use numbers loosely around here.
and check valves don't count as the valves, but whatever. Relief valves don't count as valves. So it's a must watch.
The five manual valve panel.
Yeah,
that's what it's called.
Yeah. Okay. So tune in again next week for another live edition of the Bill and Corey Show.
Set your VCRs.